Before a single muscle fiber grows, something else has to change first, and almost nobody talks about it. This is the hidden science of physical transformation. Every transformation you have ever admired started as damage, actual, microscopic, biological damage. Here's what really happens inside a body between the first workout and the one that changes everything. There is a moment every person who has ever changed their body remembers. Not the first workout, not the last. The moment somewhere in between when the mirrors stopped lying and started telling a different story. This is the story of that moment, and the science hiding inside it. When a beginner lifts a weight for the very first time, nothing about their muscle changes. Not yet. What changes first is the brain. The nervous system begins recruiting muscle fibers it has never had a reason to use before, learning to fire them together faster and in greater number. This is called neural adaptation, and it explains why a total beginner can get stronger within the first 2 weeks without gaining a single visible pound of muscle. The body is not building yet, it is rewiring. This early strength has nothing to do with size, it is coordination. The brain is learning to send a cleaner signal down the spinal cord, recruiting more motor units at once and silencing the small protective reflexes that normally hold force back. A beginner who suddenly lifts far more than expected in their first month has not transformed their muscle, they have transformed the wiring that controls it. That wiring is the foundation everything else is built on. Only after the wiring improves does the actual tissue begin to respond. Every rep of resistance training creates microscopic damage inside the muscle fiber. Tiny tears, invisible to the eye, are the real trigger of transformation. The body reads this damage as a threat and begins an emergency repair. Satellite cells activate along the outside of the fiber and fuse into it, delivering new nuclei and new material. The fiber does not just repair itself, it rebuilds thicker than it was before. This is hypertrophy, and it is the entire biological basis of the phrase getting stronger. None of this happens without a chemical conversation taking place inside the body. Mechanical tension from lifting, metabolic stress from the burn of a hard set, and the muscle damage itself all activate a pathway inside the cell called mTOR, short for mechanistic target of rapamycin. Once triggered, this pathway switches on muscle protein synthesis, the process of building new proteins faster than the body breaks old ones down. Growth is not created in the gym, it is only requested there. It is built afterward while the body rests. Not every muscle fiber answers that request the same way. The human body is built from at least 2 broad categories of fiber. Slow fibers are dense with mitochondria, resistant to fatigue and built for endurance rather than raw force. Fast fibers generate far more power, tire quickly, and hold the greatest potential for size. A beginner training for the first time is often unknowingly teaching their nervous system to recruit more of these fast fibers than it ever needed to before, which is part of why the earliest phase of a transformation can feel like waking up a part of the body that had been asleep. Underneath both fiber types lies an entirely separate transformation, one that has nothing to do with size and everything to do with fuel. The body relies on several energy systems depending on the demand placed on it. For short, explosive effort, it draws on a stored chemical reserve inside the muscle that empties within seconds. For sustained hard effort, it shifts to breaking down glucose rapidly, producing the familiar burn of a difficult set. For long-duration effort, it turns to a slower oxygen-based system, running through the mitochondria, the cellular structures often called the power plants of the cell. Training repeatedly forces the body to build more of these power plants, a process known as mitochondrial biogenesis, and it is one reason a beginner who once ran out of breath climbing a single flight of stairs can eventually sustain effort for an hour without strain. The heart transforms alongside the muscle, often before the muscle does. Consistent training increases the volume of blood the heart can pump with every beat, a measurement called stroke volume. It also increases the density of capillaries feeding oxygen to working muscle.
Together, these changes raise what physiologists call VO2 max, the maximum rate at which the body can use oxygen during effort. A rising VO2 max is one of the clearest signs that a transformation is happening far beneath the surface, long before it becomes visible in a mirror. Tendons and connective tissue are transforming too, only slower. Muscle tissue can adapt within weeks. Tendons, built largely from collagen, adapt over months, sometimes longer. This mismatch is the hidden reason so many transformations stall through injury rather than plateau. A beginner whose muscle strength outpaces the tendon and ligament tissue supporting it is, quite literally, building a stronger engine on top of an unfinished frame. Patience with the frame is not caution, it is the only way the transformation is allowed to continue at all. This is why sleep is not a luxury for anyone attempting a transformation, it is a biological requirement. Growth hormone release peaks during deep sleep, and it is during those unconscious hours that the majority of muscle repair actually takes place. A person who trains hard and sleeps poorly is requesting change from a body that has not been given permission to deliver it. Even a modest and consistent reduction in sleep has been shown to blunt the hormonal signals responsible for repair, which means a transformation can be sabotaged quietly at night by a person who never missed a single workout. Hormones shape this journey long before the results become visible.
Testosterone increases the rate of protein synthesis and supports the recruitment of satellite cells, which is one reason strength and muscle typically build at different rates across different bodies. Insulin-like growth factor, produced partly in response to growth hormone, works alongside it to extend that signal for repair well beyond the workout itself. Cortisol, the stress hormone, plays the opposite role when it stays elevated for too long, breaking down tissue rather than building it. This is why chronic stress, poor recovery, and overtraining can quietly sabotage a transformation that looks perfect on paper. The body cannot build and defend itself from constant alarm at the same time. The hormonal picture is not identical for everyone attempting this same transformation. A woman training with the exact same intensity and discipline as a man is working with a naturally different baseline of these same hormones, along with a monthly hormonal cycle that can shift energy, strength, and recovery from week to week. None of this changes the underlying biology of hypertrophy. The same torn fiber, the same repair, the same mTOR pathway apply equally. What differs is the pace and rhythm of the response, not the mechanism driving it. Genetics writes the starting conditions of every transformation without writing the ending. A protein called myostatin acts as a natural brake on muscle growth, and the amount of it produced varies from person to person, which is part of why two people can follow an identical program and grow at visibly different rates. The ratio of fast to slow fibers a person is born with also shapes how quickly size responds to training. None of this determines whether transformation is possible. It only determines its shape and its speed. Training itself has been shown to influence which genes are switched on or off inside a cell, a field called epigenetics, meaning the body a person is born with is a starting point, not a sentence. Inflammation plays a strange dual role in all of this. In the hours after a hard session, a short burst of inflammation is a necessary part of repair, signaling immune cells to clear damaged tissue and begin rebuilding. But when that inflammation never fully resolves, when training volume consistently exceeds recovery capacity, it shifts from a helpful signal into a chronic condition that blunts the very repair it was meant to support. The immune system, in this sense, is not separate from a transformation. It is one of the engineers running it. But the transformation people notice first is rarely physical. It is behavioral. Neuroscience shows that new habits are formed through a loop of cue, routine, and reward, repeated until the behavior requires less conscious effort to perform. Every time the reward arrives, whether it is relief, pride, or simply the feeling of having shown up, a small chemical signal is released that reinforces the loop, making the next repetition slightly easier than the last. In the early days of any transformation, showing up to train is a decision made through willpower. Weeks later, it becomes something closer to identity. The person is no longer forcing themselves to train. They have simply become someone who trains. This shift,
from discipline to identity, is what separates a temporary effort from a permanent transformation. Willpower itself turns out to behave differently than most people assume. Rather than a fixed reserve that runs dry, the evidence increasingly points to motivation as something closer to a skill, one that gets easier to access the more often it is practiced under difficult conditions. This is part of why the hardest workout of a transformation is rarely the 100th. It is the first, and the 5th, and the 12th, before the loop of cue, routine, and reward has had enough repetitions to start carrying part of the weight on its own. Confidence compounds in the same quiet way muscle does. Each small goal that is met, a slightly heavier lift, a slightly longer run, a slightly harder week completed as planned, feeds a person's belief in their own capability, and that belief changes how much effort they are willing to attempt next. Psychologists call this a rising sense of personal capability, and it explains why the middle of a transformation often feels faster than the beginning. It is not only the body adapting, it is a person's internal model of what they are capable of that keeps expanding alongside it. Underneath all of it lies one governing principle that never changes, regardless of age, genetics, or starting point: progressive overload. The body only adapts to demands it has not yet met. A muscle lifted with the same weight, for the same repetitions, in the same way week after week, has no biological reason to change further. It has already solved that problem. Transformation is the body being asked the slightly harder question than it was asked the week before, again and again for months. That harder question can take many forms: more rate on the bar, more total repetitions across a week, less rest between sets, a slower, more controlled range of motion. The specific method matters far less than the underlying requirement that the demand keeps rising. This is also why plateaus are not failures. They are proof that the body is caught up to the demand being placed on it. A body that is fully adapted to a given stimulus will, for a time, refuse to change further, no matter how much effort is applied, a phenomenon sometimes called adaptive resistance. This is the body defending its energy budget, refusing to spend resources on tissue it no longer sees a need for. A plateau is not the end of a transformation. It is a signal that the next question has not yet been asked, and occasionally that the body needs a deliberate week of reduced effort, often called a deload, before it is ready to keep answering. Nutrition determines whether all of this signaling has any raw material to work with. Protein supplies the amino acids satellite cells need to rebuild fiber, and research consistently points to a range of roughly 1.5 to 2 grams per kilogram of body weight daily as the range where most people training for hypertrophy see the clearest results.
So, the real question a story like this leaves behind is not whether people are good. The evidence for that is already sitting in the acts described here, and in thousands more like them that never reached a camera or headline at all. The real question is simpler and more uncomfortable: whether we are willing to be the next name in that chain. Whether we will notice the moment in front of us today, the one that asks almost nothing of us and could mean everything to someone else, and choose, quietly, without needing anyone to see it, to help. That choice, made by a stranger for a stranger, expecting nothing back, is the story that keeps restoring what the world keeps trying to take away. It has always been there. It is there right now, in someone's ordinary day, waiting to happen again.